Hello everyone, we'll start with the next method in greedy technique, that is Huffman trees and codes. This is very important, and already you have an idea about this in your DCCN. Okay, this is just with respect to encoding and decoding. Here Huffman trees deals with the it deals with how a long string or a text can be encoded and decoded so as to save the space. Here we'll use encoding and decoding to save space. I'll just tell you how you are going to save the space by using encoding and decoding. Here in this section we'll just see how the text can be encoded and how the text can be decoded. If you have a small text means it is fine, but if you have a huge text or a message that has to be transmitted from one end to another end, first it is encoded, and the encoded message is transmitted. You know the encoding and decoding, that is encryption and decryption, what you have studied in your DCCN. Okay, yes, an encoded message is transmitted, and on the other hand the encoded message will be received by one more end, and that can be decoded to get the original text or the message. This is how the Huffman tree or the Huffman code, sorry, not the Huffman tree, Huffman code will work. By using this we have to just construct a tree. Now we'll see what is this Huffman code. Okay, this Huffman code is widely used in many of the techniques for compressing and decompressing the data, that is encoding and decoding of data. First it will scans the text and find the frequency of each character. This frequency is nothing but means how much frequency that particular alphabet is having. Okay, and stores it in the form of a table. This table is used to generate the unique code for each character in the given text. Always this code is a binary character. Okay, means we'll use 0, 1, that binary thing for this code. Here we have two types of encoding schemes. The very first one is fixed length encoding and variable length encoding. Two types of fixed length encoding . Second one is variable length encoding. Always you have to remember, in both fixed length encoding and variable length encoding, always the code will be stored in the form of a table. Then it will be converted into a tree. First we'll see what is fixed length encoding. What do you mean by fixed length encoding? In the name itself it is there. In this technique, each character in the text is assigned with a bit string, okay, of the same length, and we'll consider n as the number of alphabets in the text. See, for example, in fixed length encoding you are using a binary numbers. So I'll just take first, what is the binary number? 0, 1, 1, 1, then 1, 0. Yes, all these are binary numbers. Any binary numbers, any binary numbers you can use for this one. Okay, so here you can have 0, 0 also. These are all having same length. See, even this is also having length 2, this is length 2, this is length 2, this is length 2. For example, I have some text. See, for example, I'll take S, A and then M. Before itself, for this S, for this A and M, there will be a binary code. See, for example, A, M and S. For A, the code is 0, 0. For M, the code is 0, 1. For S, the code is 1, 1. Wherever you get this SAM, then you have to replace S by 1, 1, A by 0, 0 and M by 0, 1. This is fixed length. Always it will be having the equal length of the bits. Okay, here this length of bit will be given by n. Here n is equals to 2, or I have just told you in a tabular form it will be stored. See how means here you will be having a character. This is the character. I have first A, then M, then S, then frequency. Frequency here just I'll take 100, 50 and then 70. First, what do you mean by this frequency? For example, you will be having a long text or a long text message. In that message, you have to count how many times this particular character is repeated. That is called as frequency. Frequency 100 means in that given, this is one text. In this text, 100 times A is repeated. That is the meaning of the frequency. Okay, then code. For example, I'll take n is equals to 1. N is equals to 1 means either 0 or 1. Only this is the possibility. 0, 1 and 1 I'll get. Okay, so while encoding this one, what you'll get? For A it is 0, for S it is 1, for M it is again 1. This is the encoded format. If you want to decode it in the other hand, there you need this table to decode this one, because you should know the code for each and every character. If you have this table, then easily you can just decode that. Okay. And here bit string length M, how will it, this bit string length, will consider this as M. This is the bit string length. Okay, this is your fixed length encoding. And can you just, here in this fixed length encoding, I have some disadvantages. What are the disadvantages of this fixed length encoding? Here in this fixed length encoding, actually the length of the code is fixed, so that it is very easy to identify the code without the table. If one character's code is given, means for example, if n is equals to 1, if A is equals to 0 means M is equals to 1 or S is equals to 1. Here it can be easily identified by brute force technique. So this fixed length encoding is not considered as a safe method. So in order to overcome this one, we'll go for variable length encoding. Variable length encoding. What do you mean by this variable length encoding? It is the contradiction of your this fixed length encoding. In fixed length encoding, the code length is fixed, but in variable length encoding, the code length is not fixed. You can have any length of code. Okay, see here, I'll just go with the variable length now. The same thing I'll take. This is A, this is M, and this is S. Character, frequency, and then code. Frequency, I'll just take the same thing. See here, code. For example, for A, I'll take 100. For M, I'll take 1100. For this one, I'll take 10. The code length is not fixed. Here, code length is 3. Here it is 4. Here it is 2. In any fashion, you can give the code length. For example, if I just encode this one, SAM, then what you will get? For S, I'll replace with 10. For A, I'll replace with 100. For M, I'll replace with 1100. This is the encoded format of SAM using variable length technique. Okay, in variable length technique, for the intruder, it is very difficult to find out the code, because here it is of variable length. He cannot just identify the length of the code by using brute force technique. Okay, what do you mean by brute force technique? Here it is trial and error method. All the methods you have to apply. Yes, here in our upcoming problems, we'll be just using the variable length encoding. I'll just tell you how you have to solve the problem by using this encoding and decoding technique. Okay, before that we have to just see the algorithm for Huffman tree. See, this is the algorithm for Huffman tree. The purpose is to create a tree T. I have just told you only the things, the frequency and code will be in the tabular format, but the coding and encoding technique will be found out by using tree structure here. Okay, to create a tree T, so that it has to generate the code word for given alphabets. Input is text containing various alphabets. Output is your tree T using character. Code word is the output, input is the text message. Okay. Here we don't have the pseudocode for this one. The very first step is, first you have to create n trees. Means, for example, if you have alphabets S, A and M is the alphabet. For those you have to create different trees. Create n trees where n is the number of alphabets, such that each node contains the alphabet and the frequency of the alphabet. For example, I have alphabet S, A and M. Okay, the frequency of S, here only we have taken A, M and S. Frequency of A is 100, M is 50 and S is 70. According to first step, what you have to do, create n trees where n is the number of alphabets. Number of alphabets, n is equals to 3 now, such that each node contains the alphabet and the frequency of alphabet. See, I'll create a node which contains alphabet and the frequency of alphabet. A 100, then I'll create one more node, that is M, frequency is 50. I'll create one more node, that is S, the frequency is 70. This is first step. This is step 1, what I have discussed now. See, what is step 2? Identify the two trees with smallest frequencies. Make one of them as a left child and other as the right child of a new tree. And then the sum of frequencies of left child and right child is sorted in the root node of the new tree. Repeat step 2 until a single tree is obtained. Yes, what is the meaning of this? First you have to identify the two trees with smallest frequency. Yes, here I have 3 nodes which is having smallest frequency, 2 nodes. This is 1 and this is 1. You have to make the total of this as a root node, and then you have to make any one child as the left child and any one node as the right node. So what is the total of this one? The total of this is what? It is 120. 70 plus 50, it is 120. To the left I'll write M with frequency 50. To the right I'll write S with the frequency 70. Okay, next again you have to repeat this until you get the complete. Here only one node is left out and 120, and this is A. Next, how will you just consider this one? How will you construct a tree for this? Here what you have to do, the remaining node is A 100 and then this is 120. So what you have to do, 100 and 120 you have to sum. What you will get? 220. Yes, the node A you have to take to left, that is A 100. This entire thing you have to take to right side, that is 120. M 50, then S 70. Now any other nodes are left out here? No. Our tree is done. So we have done with the second step. Now what is the third step? What is the third step? It is to get a code word for any alphabet. Here you have to get the code word, yes, which is at the leaf level. Start from root node till the leaf level node is obtained. Here what you have to do is, see here, from the root node till leaf node you have to do. What you have to do, all the left nodes should be marked as 0 and all the right nodes should be marked as 1. How will you just do this one? Yes, see here only left side it is 0. Okay, this is right one, this is 1. For this node again M is the left node, then S is the right node. Again I'll write 1. Now you have to just find out the code word for this one. For A, for reaching the node A, what is the code word? It is 0. To M, what is the code word? See, from here to here you have to count. From here 1, then 0. 1 0 is the code word for M. Then for S, what is the code word? See, it is 1 and then 1. 1 1 is the code word. So for Sam, what is the code word encoded format? 1 1 0 and 1 0. This is the encoded format for Sam. This is how we'll just do the Huffman code using Huffman trees. This is called as the Huffman tree. Sometimes in the place of frequency they can just give the probability. There is no problem. If they give probability also, you have to do the same thing. In the next video, I'll just tell you how you have to solve the problem. Okay, this is your Huffman coding. In this you have to remember this. In this we use the technique of encoding and decoding. Okay, and then we have two types, that is fixed length encoding and variable length encoding. Fixed length encoding is having some limitations. To overcome that, they have introduced the variable length encoding. Always we have to use the variable length encoding. Okay, and you have to just remember the steps in algorithm, 3 steps. Okay, in the next video we'll come up with a problem. Thank you.